Okay, so direct proportion. All right. It's usually two things that we might have to do in an exam. We might have to actually show that it's a direct proportion relationship. All right. Show that two variables are directly proportional. Or we might need to determine the rule or relationship, or even both. All right. So prove it's direct proportion, and what should the rule be? So how are the variables linked? All right. So let's get stuck into it. So is this a direct proportional relationship? So you're given a table of values and they want you to say yes or no, it is a direct proportion relationship. So you have to explain why. So the first check you do is across your horizontal section. So I want to check my X values and see if they're increasing at a constant rate. Okay. X is increasing. Let's see if it's at a constant rate though. So for 0 to get to 1, we add 1. For 1 to get to 2, we add 1. For 2 to get to 3, we add 1, and etc. All right. So we can say, okay, our first little condition is met. So X increases at constant rate. I wish that I could write neater on this thing. All right. So X increases at a constant rate. Then we want to check whether Y increases at a constant rate. So we're looking at the bottom row of the table's values. So it does increase at a constant rate. Okay. This number is the same between consecutive Y values. We've got our change in Y values is 4. All right. So Y increases at a constant rate. So that's nice. And then our last little check is if it passes through the point 0, 0. So in other words, at X equals 0, does Y equal 0? So we can find that from the graph. At X equals 0, Y does equal 0. If only I could, yeah, all right. Okay, so we're looking good. We've got all of these satisfied. Therefore, direct proportion. Okay, or we could also write Y is proportional to X. Okay, and now for this one, we just check the same thing. So we've got these three little conditions. All right, for direct proportion. And we've just got to check them every time, whether it's a graph or a table. All right, so what I might do before we go in is show you what a graph of this would look like. So we've got our table of values. Usually we want to plot a graph from there. Okay, so you definitely want to know how to plot a graph. All right, so I can see I've got the point 0, 0. I've got the point, I'll just label my X and Y axes. I've got the point 1 is to 4. It's not to scale. 2 is to 8, etc. You only need 2 points to plot a straight line. And as you can see, the graph of a directly proportional relationship passes through the point 0, 0 and is linear. Okay, so this bit here means that it's linear, so a straight line. And this bit here means that it passes through the origin. Oh dear. Okay. So yeah, let's have a look here. So what about this one? Is this a directly proportional relationship? So we do the check again. Okay, step 1. All right, we look at our top row of the table. Is T increasing at a constant rate? It appears to be so. Okay, so we can say 1, T increases at constant rate. Step 2, we check our C values, which were just our Y values up here, all right? C is, let's have a look. Is it increasing at a constant rate? Okay, 5 plus 5 is 10, 10 plus 5 is 15, 15, okay. All right, C is increasing at a constant rate. And then we've just got to do our third and final check, which is at x equals 0, does y equal 0? So we come to the top of our table. We look for, because this is our little sort of x, y. We look for t equals 0. And what's our y value? It's 5. So that's not right. So at t equals 0, that's not directly proportional, I mean. So at t equals 0, C equals 5. So I'm just reading off the table there. Okay, not 0, therefore not directly proportional. Okay, it has to satisfy all 3 conditions. It satisfied the first 2, but it didn't satisfy the last one. All right, so let's have a look up here. What have we got? So yeah, you might want to just like copy down this slide. So we've got 2 conditions need to be satisfied for direct proportion. All right, so you check amongst the x and y values whether they're increasing by a constant amount. And you'll also check whether it passes, whether at x equals 0, y equals 0, which needs to happen. All right. All right, so determining the rule given direct proportion. So now we know how to, like, when we see it, whether it looks like direct proportion or not. But how do we determine the rule? All right, so immediately, whenever they say given direct proportion, I immediately write down y equals kx. All right. And then what you have to do, you're determining the rule, right? So the rule means we want to link y with x. So we need to find k. Need to find k. So a value for k and then substitute it back in. All right. So looking at this equation, I can see that there's a y, a k, and an x. So k is my unknown. I actually have a whole table of values here. So I can just take 1 point from this table. I'm not going to choose 0, 0 because then both sides of the equation will be 0. But I might choose 2, 8. All right. And I can substitute it in. Sub in 2, 8, which is just an x, y point. So x is 2, y is 8. So let's chuck it in. So y equals kx, therefore 8 equals k times 2. Remember, kx is the same as k multiplied by x, not subtract, as I've seen a lot of students do. All right, now we've just got to rearrange for that k and then substitute it back in. All right, so k will be 8 divided by 2, since I divide both sides by 2, and I get k equals 4. Okay, sub k equals 4 into equation, into y equals kx. And then you've just got, so an equation is in terms of y and x. Our k value was 4. So that's how we link y with x, with that little k value. All right, so what about this one? So I can see that, what have we got? It passes, so I'm just checking direct proportion. It passes through the point 0, 0. X and y values are increasing at the same rate. And there's actually another way that you can find k, which I will show you here. So I'll show you in this first example. All right, I'm going to show you. So what is 0 divided by 0? 0. What's 4 divided by 1? It's 4. What's 2? So I'm just going to write it down here. 4 4 divided by 1 is 4. 8 divided by 2 is 4. 12 divided by 3 is 4. 16 divided by 4 is 4. So see how there's a constant value between each of them? Okay, 8 divided by 2, 12 divided by 3. So remember to divide your second row by your first row, the corresponding values. All right, so what do we notice? We notice that that value is the K value. So K is constant throughout. It's how we link the X and Y values. All right. So hopefully that helps. Have a little go at that at home. And I will, in my next video, do some word problems. Yes.